The Great Pyramid of Giza holds a secret written in starlight. This is the profound mystery of astral engineering, where ancient monuments were precisely built to interact with the cosmos. We are going on a journey from the deserts of Egypt to the mountains of Peru, investigating how stone and sky were fused together with impossible accuracy. By the end, you will see the constellations not as distant lights, but as a forgotten blueprint for our world's oldest structures. How did cultures across the globe with no apparent connection achieve such celestial precision? What were they trying to accomplish by anchoring their greatest buildings to the motions of the sun and stars? The answers force us to rewrite everything we assume about ancient technology and human potential. What does it mean for a civilization to build its faith into the very foundation of the earth? For most of us today, the night sky is a beautiful but silent backdrop. We see it through the glare of city lights, a scattering of stars that seems disconnected from the ground beneath our feet. But step back thousands of years and the entire relationship flips. The sky was not a passive painting. It was a dynamic, living map. It was a clock that told the seasons, a calendar that predicted the floods, and a storybook written in constellations. This fundamental shift in perception is the first key to unlocking the mystery. It leads us to a powerful idea we call astral engineering. Astral engineering is more than just ancient astronomy. It is the deliberate, physical fusion of architecture and the cosmos. It represents a society's decision to take its understanding of celestial patterns and literally build it into the earth. We are not talking about rough approximations or symbolic gestures. We are discussing precise, reproducible alignments engineered into stone, a temple doorway that captures the first ray of the summer solstice sun, not just once, but every single year. A narrow corridor that frames the rising of a specific star on one particular night, marking a sacred date. A massive pyramid whose sides are oriented to the cardinal directions with an accuracy that rivals modern instruments. This concept forces a collaboration between fields that rarely speak the same language. Archaeologists examine the stones, astronomers calculate the ancient skies. Architects study the intent behind the design. When these disciplines converge, a new picture emerges, one that compels us to radically reconsider the intellectual ambition of our ancestors. It moves the discussion from what they built to why they built it that way. The precision itself is a form of communication, a message carved in geometry and sunlight meant to last for millennia. So let's reframe the question with a modern analogy. If we discovered a skyscraper built today whose glass facade was designed to reflect a beam of light onto a specific point in the city only on the anniversary of its founding, would we call that a lucky accident? Or would we immediately recognize it as brilliant, intentional design? This is the lens we must now apply to the monuments that have stood silently under the stars for thousands of years. Their alignments are not random, they are signatures. That first moment of dawn was their original textbook. Every ancient culture, from the earliest settlements, began their education in celestial engineering by simply watching the horizon. They saw the sun did not rise in a random spot each day. It marched along the horizon, moving northward as the days grew warmer and southward as they grew colder. This path, this predictable highway of the sun across the sky, is what astronomers call the ecliptic. Recognizing this pattern was the first, most critical step. It meant the sky was orderly. It meant you could build a calendar in stone because you could predict where the sun would be on a specific future date, year after year. But the sky's clockwork is built with several interlocking gears. Beyond the dependable sun, they track the moon's more complex cycle of phases and its own wandering path. And they mapped the fixed stars, those seemingly eternal pinpricks of light that rotated nightly around two silent, unmoving points in the heavens, the celestial poles. Finding true north wasn't about a magnetic compass, it was about observing which star, night after night, refused to move from the center of the sky's great turning wheel. This gave them the cardinal directions, a sacred and practical framework upon which they could anchor their entire world. Yet here we encounter the first truly profound challenge these ancient sky watchers had to solve, a phenomenon that reveals the depth of their long-term observation. The Earth's axis slowly wobbles like a spinning top over a cycle of about 26,000 years. This is called the precession of the equinoxes. What it means is that the celestial pole, that fixed point in the northern sky, is not permanently fixed. The star we call Polaris, our North Star today, was not always the pole star. In the time of the pyramid builders, a different star, Thuban in the constellation Draco, held that position. This is not a rapid change. It shifts by about 1 degree every 72 years, a change nearly imperceptible across a single human lifetime. But across centuries and millennia, it is dramatic. For a monument to be aligned to true celestial north, its builders needed data collected over generations. They had to distinguish between the temporary pole star and the actual, mathematical point around which the sky turns. The staggering implication is that some ancient sites appear to be aligned not to the pole star of their own era, but to the ideal, abstract celestial pole itself. This is the difference between building a sundial and building a clock that accounts for the gradual slowing of the Earth's rotation. It suggests a tradition of sky observation so meticulous and so faithfully passed down that it could compensate for a cosmic drift invisible to any individual observer. This foundational knowledge, the ecliptic, the lunar nodes, the precession, these were the silent, invisible tools. They were the theorems and equations that existed long before paper, understood through patient watching and encoded in stories. With this celestial compass in mind, we can finally look at the stones not just as a building, but as a permanent, physical record of that hard-won sky knowledge. The architecture becomes a frozen snapshot of the heavens at a precise moment in deep time. Standing in the desert on a crisp winter night, the sky above Giza is a breathtaking, overwhelming presence. The familiar constellations of home vanish, replaced by a brilliant, unfamiliar tapestry, and there, dominating the southern sky, hangs the unmistakable figure of Orion the Hunter, his belt of 3 bright stars slicing a perfect line through the darkness. It is an awe-inspiring sight, one the pyramid builders knew intimately. This visceral connection between the sands and the stars forms the heart of one of history's most provocative archaeological theories. In the 1990s, author Robert Bovell proposed a radical idea that electrified the public imagination and ignited fierce academic debate. He suggested the ground plan of the Giza Plateau was not a random arrangement of tombs, but a deliberate, scaled-down map of the heavens. Specifically, he argued that the 3 great pyramids of Khufu, Khafre, and Menkaure were built to mirror the 3 stars of Orion's belt. The correlation is visually striking. The 2 larger pyramids align with the 2 brighter belt stars, while the slightly offset, smaller third pyramid matches the dimmer, offset third star. Furthermore, Bovell and others noted that the pattern of the pyramids on the ground, when viewed from above, appears to match the slight kink or asymmetry in the celestial belt's arrangement. This was not just about general symbolism, he argued. It was about a specific, intended correlation. The theory delves deeper into the pyramid's internal architecture. The Great Pyramid contains narrow, sloping shafts, often called air shafts, emanating from its central chambers. Egyptologists long debated their purpose. Bovell's work, later supported by astronomical software, proposed a stunning function. These shafts were not for ventilation, but for precise celestial sightlines. Calculations indicate that around 2500 BCE, when the pyramid was built, the southern shaft from the so-called King's Chamber would have pointed directly at the heart of Orion, associated with the god Osiris. The northern shaft from the same chamber would have framed the star Thuban, which was the pole star of that era. Meanwhile, shafts from the Queen's Chamber aligned with the bright star Sirius, linked to the goddess Isis, and with the star Kochab, another important circumpolar marker. The implication is staggering. The pyramid becomes less a static tomb and more a kind of stone planetarium, a machine designed to capture and channel specific celestial energies at specific times, connecting the pharaoh's journey with the eternal cycles of the cosmos. This idea, however, sits at the center of a heated scholarly divide. Mainstream Egyptology often views the correlations as interesting but coincidental, or at best broadly symbolic. They point out that the ancient Egyptians did not leave explicit texts describing such a precise stellar blueprint. The primary religious texts, the pyramid texts, speak of the pharaoh joining the stars, but not of building a terrestrial map of Orion. Critics argue that with so many stars in the sky, finding patterns that match ground features is a statistical possibility, not proof of intent. Archaeoastronomers, scientists who specialize in ancient sky lore, take a more measured view. They acknowledge the precise alignments of the shafts are difficult to dismiss as accident. The engineering required to angle those long, internal tunnels through millions of stone blocks is immense, suggesting a powerful purpose. The debate, then, is not about whether the Egyptians were master astronomers. They clearly were. It is about interpreting the depth of their ambition. Was Orion's belt a general spiritual inspiration, or was it a precise architectural template? The Giza Plateau presents us with our first major puzzle in stone and starlight. It forces us to ask whether we have underestimated the technical specificity of ancient symbolic thought. Can a symbol be so meticulously engineered that it becomes a functional part of the universe it represents? The debate over Giza is a clash of interpretations of symbols versus blueprints. To find a clearer answer, we must travel from the dry precision of the Egyptian desert to the misty, wind-swept plains of southern England. Here stands a monument whose purpose feels even more enigmatic, a ring of massive sarsen stones that seems to grow from the earth itself, Stonehenge. For centuries, it was seen as a druid temple or a primitive calendar, but modern research paints a far more sophisticated picture. It reveals a structure that may have functioned as a kind of Neolithic computer, engineered not just to mark time, but to predict one of the most awe-inspiring and frightening events in the ancient sky, a total eclipse. Picture the scene on the morning of the summer solstice. The sky over Salisbury Plain is a pale, pre-dawn gray. A crowd gathers within and around the stone circle, their breath visible in the cool air. All eyes are fixed on a single, massive upright stone set apart from the main ring, known as the heel stone. As the sun crests the distant horizon, a brilliant, razor-thin beam of light slices through the atmosphere. It passes perfectly between the pillars of the Great Trilithon, the central horseshoe of towering stones, and strikes the recumbent altar stone at the heart of the monument. This is not an accident. It is a feat of engineering orchestrated to happen on one specific day each year, a day that marks the sun's peak power. The entire central axis of Stonehenge is aligned to this solstitial sunrise and in the opposite direction to the winter solstice sunset. Achieving this alignment required not just careful observation, but the transfer of that knowledge across generations, long before the first colossal sarsen stone was ever dragged to the site. But the story of Stonehenge's celestial purpose grows deeper and more complex when we look beyond the sun. Around the inner edge of the circular bank that encloses the stones, archaeologists have identified a ring of 56 pits, now known as the Aubrey holes. For decades, their function was a mystery. Then, a startling astronomical connection emerged. the cycle of eclipses, both solar and lunar, is governed by a complex pattern. One of the most important cycles is called the Saros cycle. It is a period of approximately 18 years and 11 days, after which the Sun, Earth, and Moon return to nearly the same relative geometry, and a similar eclipse will occur. But here is the crucial detail: 3 Saros cycles add up to 56 years. Could the 56 Aubrey holes have been a counting mechanism, a physical calendar used to track this 56-year eclipse cycle? The idea is compelling. In a society that saw the heavens as a direct expression of divine will, an eclipse was not a mere spectacle. It was a moment of profound cosmic crisis. The sun, the source of all life, could be swallowed by darkness in the middle of the day. The moon could turn a deep, ominous red. To be able to predict such an event would have been an act of immense power and social necessity. It would transform terror into ritual, chaos into a scheduled, sacred drama. The priests or astronomers who could stand before the people and say, "The gods will darken the sun on this day," were not just stargazers. They were the keepers of cosmic order. The investment becomes clear. Why would a Neolithic society dedicate centuries of backbreaking labor to quarrying, transporting, and erecting 80-ton stones? Perhaps because the structure was essential. It was a permanent, immutable reference library built from rock, a machine designed to harmonize human society with the sometimes terrifying rhythms of the cosmos. It provided a predictable framework for the unpredictable, so we are left with a haunting question. What deep, primal need drives a culture to encode the mathematics of the heavens into a monument of earth and stone? The answer seems to lie in a fundamental human desire to find pattern in chaos, to build meaning against the vast, silent backdrop of the universe. The precision of Stonehenge reveals a mind seeking to predict cosmic order, but in Egypt, another civilization engineered its monuments to become a direct participant in that order. We leave the open plain for the confines of a colossal stone forest. The Temple of Karnak is not a single building, but a sprawling complex of sanctuaries, lakes, and pylons built and expanded over 2,000 years. At its heart lies the hypostyle hall, a cavernous space filled with 134 towering stone pillars, the largest such hall on Earth. For most of the year, this hall is a place of profound, permanent shadow, a stone representation of the primordial darkness before creation. But for a few precious minutes on a handful of mornings around the December solstice, something miraculous happens. As the sun rises on the shortest day of the year, a beam of light finds the central axis of the entire temple complex. It penetrates the first pylon gate, travels down the long, open courtyard, slips between the impossibly dense columns of the hypostyle hall, and continues down a final, narrow corridor. Its final destination is the innermost sanctuary, the Holy of Holies, the windowless granite chamber that housed the statue of the supreme god Amun-Ra. In that moment, the darkness is pierced. The god's dwelling is flooded with the reborn light of the solstice sun. This was not a happy accident. It was the culmination of a staggering engineering project that spanned centuries. To achieve this, the temple's main axis had to be oriented with exquisite care. A fraction of a degree off, and the beam of light would be blocked by a pillar or a wall. The architects were not just building for their own generation. They were planning for a celestial event that would recur every year, long after their names were forgotten. They had to account for the sun's precise angle on the horizon on that specific day, an angle that changes imperceptibly over centuries due to the Earth's axial precession. This means the alignment built during the New Kingdom period would have been even more perfect then than it appears today. The theological meaning here is everything. In Egyptian belief, the sun god Ra underwent a nightly journey through the underworld, facing challenges to be reborn at dawn. The December solstice represented the peak of this struggle, the longest night, the moment of the sun's greatest weakness and most triumphant return. By engineering the temple to capture this specific sunrise, the priests were performing the ultimate act of sympathetic magic. They were not just celebrating the sun's rebirth, they were actively causing it, using architecture to pull the sun's life-giving power into the statue of the god, and by extension, into the person of the pharaoh and the entire kingdom of Egypt. This shifts our understanding of celestial precision dramatically. At Giza, the alignments may guide a soul to the stars. At Stonehenge, they predict cosmic events. But at Karnak, the architecture itself becomes the ritual. The temple is a machine for making mythology physically real, for turning belief into a beam of sunlight you can see and feel. It merges state power, religious authority, and astronomical knowledge into a single, undeniable spectacle witnessed by the priesthood and symbolically by the nation. This transforms the temple from a place of worship into a cosmic battery, recharged annually by the sun's most vulnerable yet most persistent light. It makes you wonder, what does it mean for a civilization to so deeply trust its understanding of the cosmos that it would invest centuries of labor to build a proof of its faith in stone? Deep within a grassy mound in the Irish countryside lies a chamber of perpetual night. Newgrange is a passage tomb built over 5,000 years ago, older than Stonehenge, older than the pyramids of Giza. To enter is to leave the modern world behind, crawling down a narrow, 60-foot-long tunnel lined with immense carved stones into a central cruciform chamber shrouded in a silence so thick it feels solid. This was a house for the ancestors, a resting place of eternal darkness. Yet, once a year, this tomb performs a miracle of light. Above the entrance, hidden within the mound structure, is a small, rectangular opening called the roof box. It is not an accident or a later addition, but a meticulously engineered aperture built from carefully slotted stone slabs. For a few days centered on the winter solstice, at dawn, if the sky is clear, a brilliant shaft of sunlight enters this roof box. It does not flood the entrance, it penetrates with purpose. The beam, no wider than a hand, travels the entire length of the dark passageway, a golden finger reaching through the gloom until it strikes the rear wall of the central chamber. For precisely 17 minutes, the heart of this house of death is bathed in a warm, living light. Then, as slowly as it arrived, the light retreats, and the tomb returns to its year-long vigil of darkness. The engineering precision required to make this happen is astounding. The builders had to calculate the sun's extremely low angle on the horizon at the winter solstice. They had to construct the roof box at the exact height and orientation so the beam would travel in a perfectly straight line down a passage that itself rises slightly from the entrance. A miscalculation of a single degree or the misplacement of a single roof slab and the phenomenon would fail. This was not a monument to the sun at its height, but to the sun at its lowest ebb, at the moment of its greatest symbolic death. In a society utterly dependent on agriculture, the winter solstice was the turning point, the longest night after which the days would slowly grow longer and the promise of spring would return. Newgrange embodies this hope in stone and sunlight. It is a profound statement about the cycle of existence where life emerges from death and light is reborn from the deepest dark. The ancestors within were not seen as gone, but as part of this eternal cycle. The annual illumination was likely a sacred event, a moment when the boundary between the living and the dead, between the earth and the sky, grew thin and permeable. Here, astral engineering served the most intimate of human needs, to find reassurance in the cosmos, to see a promise of renewal written in the annual journey of the sun. It transforms a tomb from a place of ending into a mechanism of rebirth, a stone calendar that marks not just the passage of time, but the enduring victory of light. High in the Andes, where the air grows thin and clouds cling to jagged peaks, sits a stone that seems to converse directly with the sky. At the heart of the lost city of Machu Picchu, perched atop a sacred pyramid, is the Intihuatana. Its name translates to the hitching post of the sun, and to stand before it is to witness a perfect fusion of mountain, stone, and celestial mechanics. This is not a sprawling temple or a towering pyramid, but a single, elegant pillar of granite, carved with exquisite care directly from the bedrock of the mountain itself. Its four sides are precisely aligned to the cardinal directions, and its top is a complex, multifaceted prism, each angle and plane sculpted with intention. This was no abstract sculpture. It was a supremely sophisticated instrument, a master clock and calendar carved from living rock. On the equinoxes, the day when light and dark are perfectly balanced across the globe, something extraordinary happens. As the sun reaches its zenith, the stone casts no shadow at all. The pillar stands in complete, shadowless unity with the sun directly overhead, a moment of perfect alignment that must have felt like the stopping of time itself. On the solstices, the longest and shortest days, the shadows it casts trace specific, predictable paths along its carved grooves and across the platform, marking the sun's extreme northern and southern turning points in its annual journey. The precision encoded in this single stone is breathtaking. Without written records, without telescopes or metal tools, the Inca astronomers engineered a device that could track the solar year with unerring accuracy. This knowledge was the lifeblood of an empire stretched across some of the most extreme terrain on Earth. From this sacred center, the calendar derived from the Intihuatana's readings dictated the entire rhythm of the Inca world. It told farmers in distant valleys precisely when to plant and when to harvest. It scheduled the immense religious festivals that bound the empire together, where the Sapa Inca, the emperor believed to be a descendant of the sun, would perform rituals to ensure the sun's continued journey and, by extension, the survival of his people. The stone was more than a tool, it was an anchor. In their cosmology, the sun was a divine force that needed to be tethered to the earth each day to prevent it from wandering away and leaving the world in permanent night. The Intihuatana was that tether, the physical point where the sun was symbolically hitched to the mountain, guaranteeing its return. This transforms our understanding of astral engineering once more. Here, celestial precision is not locked into a single, immovable alignment like at Karnak, nor is it a massive public spectacle like at Stonehenge. It is a portable principle, a master template of knowledge that could be understood from one precisely carved object and then communicated across thousands of miles of mountain roads. The empire was administered by the sun's schedule, and that schedule was read from the silent, shadow-casting angles of a single stone. It represents a distillation of cosmic law into a form of elegant, functional art, proving that the deepest astronomical wisdom can be held in the palm of a mountain, waiting for the right day, the right light to speak its truth. The stone at Machu Picchu stands alone, a masterwork of isolated genius, but pull back, far back, until the entire globe spins into view. A startling pattern emerges. Scattered across continents and millennia, from the jungles of Central America to the plains of North America, from the deserts of Egypt to the plains of China, are monuments that share this one profound trait, a silent dialogue with the heavens. The Maya built pyramid temples like El Castillo at Chichen Itza, where the setting sun on the equinoxes creates a serpent of light slithering down the staircase. The ancient Chinese aligned their imperial cities and tombs along precise north-south axes, mirroring the celestial order they called the Mandate of Heaven. In what is now the United States, the Mississippian culture constructed enormous earthen mounds like Cahokia's Woodhenge, a circle of wooden posts that tracked the solstices and equinoxes, much like its stone namesake across the Atlantic. This is the central, haunting mystery of astral engineering. How did cultures with no known contact, separated by vast oceans and thousands of years, independently arrive at the same monumental conclusion, to build their grandest structures as reflections of the cosmos? The search for an answer leads us down several compelling paths. The first is the simplest and perhaps the most profound, a universal human response to the sky. Every single human in every culture, in every epoch, has looked up at the same sun, moon, and stars. The awe, the curiosity, the desire to find meaning in those lights is a shared birthright of our species. From that common starting point, the practical necessities of survival provided a powerful impetus. The development of agriculture demanded a reliable calendar. Knowing when to plant before the rains came or when to harvest before the frost was a matter of life and death. The most dependable clock available was the sky. By marking the solstices and equinoxes with permanent stone markers, a society could secure its food supply, transforming celestial observation from philosophy into essential infrastructure. Yet another thread connects these global efforts, the powerful link between cosmic knowledge and earthly authority. In almost every early civilization, the ruler or priestly class derived their legitimacy from a special connection to the divine. What could be more divine than demonstrating command over the very motions of the heavens? A pharaoh who could predict the Nile's flood by the rising of Sirius, or a king who could announce the sun's rebirth from a specially engineered temple, was not just a political leader. They were a mediator between the people and the cosmic order, a living guarantee of stability and favor from the gods. The monument became proof of that sacred contract, written in alignments so precise they could only be the work of divinely inspired knowledge. To make sense of this global tapestry, a unique scientific discipline was born: Archaeoastronomy. It sits at the crossroads of archaeology and astronomy, patiently disentangling the intentional from the coincidental. An archaeoastronomer might spend years measuring the alignments of a temple, then run sophisticated software to rewind the sky to the date of its construction, asking a simple but revolutionary question: what star or sun would have been framed in that doorway 3,000 years ago? Their work moves us beyond speculation, providing mathematical evidence for the mind behind the monument. What this field reveals is not evidence of a single, lost super-civilization, but something perhaps more meaningful: a fundamental human endeavor. It suggests that the drive to encode cosmic law into terrestrial form is not an anomaly, but a recurring feature of our cultural development. We are, it seems, a species hardwired to seek the pattern, to build our meaning, and to anchor our greatest hopes in the silent, predictable dance of the lights above. The shadow cast by a simple stick in the ground holds more power than we might think. We often assume that celestial precision on a monumental scale must have required equally monumental technology, some lost device of impossible complexity. But the true genius of these ancient engineers lies in their ability to extract profound accuracy from breathtakingly simple tools. Their toolbox was one of observation, patience, and an intimate understanding of basic geometry. Consider the Gnomon, perhaps the most fundamental instrument of all. It is nothing more than a vertical stake driven into level ground. Yet, by meticulously marking the tip of its shadow at different times of day, an observer can map the sun's path, determine true north and south, and even pinpoint the exact dates of the equinoxes when the shadow's path is a perfectly straight line. This humble tool transforms a patch of Earth into a solar observatory. In Egypt, a more specialized device took this principle further. The Merkhet was a sighting tool made from a palm rib with a slit in it, used alongside a plumb line, a simple weight on a string. An astronomer, known as a stretcher of the cord, would use one Merkhet to sight a specific star. A second person, some distance away with another Merkhet and plumb line, would align themselves until both observers formed a perfect straight line with the star. By marking these points on the ground, they could establish a true meridian line, an exact north-south axis, with astonishing accuracy. This method was likely used to align the colossal sides of the Great Pyramid, achieving an error of less than 1/15 of a degree. But how do you level the foundation for such a massive structure across acres of uneven desert? The answer is elegantly simple. They dug a shallow grid of trenches across the building site and filled them with water. Water, they knew, always finds its own level. By marking the waterline at various points in the trenches, they created a perfect horizontal reference plane across the entire site, a liquid horizon against which every stone could be measured. This is engineering that understands the fundamental laws of nature and uses them as a guide. Perhaps the most beautiful demonstration of this grounded genius is a method often called the Indian circle. To find true east and west without any modern instruments, an observer would plant a central gnomon. As the sun rose, they would mark the tip of the shadow. They would then draw a wide circle on the ground using the length of the shadow as the radius. Throughout the day, they would watch as the shadow shortened and then lengthened again. In the afternoon, when the shadow's tip once again touched the circumference of that same circle, they would mark that spot. A straight line drawn between the morning and afternoon marks gives a precise east-west axis. The equinox line, when day and night are equal, is found by connecting the 2 points where the shadow's path is a straight line. These are not the tools of a mysterious, lost science. They are the tools of relentless dedication. They required no lenses or gears, only a deep understanding of shadow, light, and the consistent behavior of the physical world. This demystifies the ancient achievements, not by diminishing them, but by elevating the power of cumulative human knowledge. It shows that precision is not born from magical devices, but from generations of watchful eyes recording the slow dance of shadows on stone and sand. The true instrument was time itself, and the unwavering belief that the cosmos spoke a language that could be understood, measured, and finally, built into the bones of the earth. Stone and shadow gave them a calendar, but stories gave that calendar a soul. The monuments we have walked through were not built by emotionless surveyors following a technical manual. They were born from a universe alive with gods, heroes, and epic tales. This is where the pure engineering of alignments merges with the human heart of the endeavor, for mythology was the ancient language of astronomy. These stories were not mere fantasies, they were the narrative containers for generations of hard-won celestial observation, a way to remember and teach the patterns of the sky long before written records. In Egypt, the night sky itself was a goddess, Nut, depicted as a woman whose star-studded body arched over the earth, her fingers and toes touching the horizons. Each evening, she was said to swallow the sun, which then traveled through her starry body to be reborn from her mouth at dawn. This is a breathtakingly beautiful metaphor, but it is also a precise cosmological model. It encodes the observable reality of the sun's nightly journey beneath the horizon and its reappearance, mapping the ecliptic path onto a divine, maternal form. The pyramids, those gateways to the stars, were physical instruments to help the pharaoh's soul navigate that very body, to join the eternal cycle within the goddess. Across the ancient world, other myths seem to hold celestial memories. The Epic of Gilgamesh, one of humanity's oldest written stories, contains a flood narrative of immense power. Scholars have long wondered if this could preserve a cultural memory of a real, catastrophic event. But look to the sky and another layer appears. The hero's journey, his battles and losses, may also mirror the movements of constellations known to the Mesopotamians, turning the epic into a celestial map recited around fires for centuries. Then there is Orion, the mighty hunter. In Greek myth, he was killed by a scorpion and placed in the stars, forever pursued by the constellation Scorpius across the heavens. This story perfectly captures the astronomical reality, as Orion and Scorpius are opposite each other in the sky. When one rises, the other sets, locked in an eternal, mythical chase. These narratives did more than explain, they preserved. They turned complex observational data about seasonal appearances and disappearances of star groups into unforgettable characters and conflicts. This leads us to a profound reflective question. were the great monuments built not just to measure the sky, but to physically enact these myths, to make the stories tangible for the entire community. Consider the solstice alignment at Karnak. That beam of light entering the dark sanctuary is not just a solar event. It is the dramatic climax of the myth of Ra's rebirth, performed by architecture itself. At Newgrange, the sun's penetration into the tomb's deepest chamber is a literal enactment of the life from death promise central to their beliefs. The monument becomes the stage, the sun the actor, and the gathered people the audience, witnessing their most sacred truths made manifest in light and shadow. This layer transforms our understanding completely. Astral engineering was never just about measurement for survival or power. It was about meaning. It was about weaving the community's identity, its hopes about life and death, and its relationship with the divine directly into the landscape. The stones held the measurements, but the myths gave those measurements a purpose that resonated in the human spirit. They were building memory itself into the horizon, ensuring that the story of who they were and what they believed would outlast empires, written not on fragile parchment, but in the immutable dialogue between their temples and the turning sky. That promise written in light and shadow faces its greatest challenge from the sky itself. The Earth is not a perfectly still sphere in space. It spins, but that spin has a slow, majestic wobble, like a giant top gradually tracing a circle over a span of 26,000 years. Astronomers call this the precession of the equinoxes. What it means is that the entire starry backdrop against which the sun rises and sets is constantly, imperceptibly drifting. The constellation that appears behind the sun on the spring equinox today is not the same constellation that was there 2,000 years ago. This shift marks the great astrological ages, the age of Pisces, the coming age of Aquarius, each lasting over 2,000 years as the equinox sun dawns against a new celestial sign. This presents a fascinating puzzle for archaeoastronomy. If a temple is aligned to the rising sun on an equinox, and its builders also carved imagery of a specific constellation on its walls, that gives us a powerful clue. We can essentially rewind the sky using astronomy software. We can ask, in what era did the sun rise in that exact spot, framed by that specific doorway, with that specific constellation directly behind it? The alignment becomes a celestial timestamp, a date written in stone and starlight. This leads to one of the most controversial and captivating theories in alternative history, centered on the Great Sphinx of Giza. The Sphinx is a colossal limestone statue with the body of a lion and the head of a pharaoh, traditionally dated to around 2500 BCE, the Old Kingdom period. But some researchers looking at the precession puzzle propose a radically different story. They note that the Sphinx faces due east, gazing directly at the equinox sunrise. In the epoch of its traditional dating, the sun on the spring equinox would have risen in the constellation Taurus, yet the Sphinx itself is a lion. So the theory asks, what if the lion body is not just a random royal symbol, but a direct representation of the constellation in the sky at the time of its construction? If you wind the celestial clock back much further, to around 10,500 BCE, something extraordinary aligns. On the spring equinox of that remote era, the sun would have risen directly in the constellation Leo, the lion, hovering above the horizon in the exact spot the Sphinx eternally watches. Proponents like author Graham Hancock suggest this is not a coincidence. They propose the Sphinx, or at least its core body, could be a monument from that vastly older time, a lion watching its own celestial counterpart. The erosion patterns on the Sphinx's body, they argue, appear more consistent with water weathering from heavy rainfall than wind and sand, and the last period of significant rainfall in Egypt ended around the same time, after the last ice age. This idea, of course, stands in stark opposition to mainstream Egyptology, which places the Sphinx firmly in the Old Kingdom, and attributes the erosion to wind, sand, and chemical weathering from morning dew. The debate is intense, often framed as a clash between rigid academia and speculative revisionism. But at its core, the precession theory forces a profound question that transcends any single monument. It asks us to consider the possible scales of human history. If the alignments are intentional, they suggest two staggering possibilities, neither of which fits comfortably into our conventional timeline. First, the monuments themselves could be far, far older than we currently believe, remnants of a sophisticated culture lost to the cataclysms of prehistory. Second, and perhaps even more challenging to our worldview, is the possibility of a long, unbroken tradition of knowledge. This would mean that even if the Sphinx was carved in 2500 BCE, its builders possessed astronomical data so precise, so ancient, that it recorded the sky from 8,000 years before their own time. They would have been building a monument to a celestial event their civilization had never physically witnessed, guided by a wisdom passed down across hundreds of generations through myth, ritual, and meticulous oral tradition. This transforms the Sphinx and any monument like it from a simple statue into a potential time capsule. It is not just a message left for the future, but one that may have been received from a past so distant it borders on legend. The wobble of the Earth's axis becomes the key to a lock we are only beginning to recognize, a lock on a door that might lead us to reconsider the entire narrative of human achievement. The silent stones may have held another language entirely, one not of light but of sound. Beyond the visual alignments, a new frontier of research is asking us to listen to these ancient sites, to hear the messages they might have been designed to carry. This is the emerging field of archaeoacoustics, the study of sound in archaeological contexts, and it reveals a dimension of astral engineering that engages an entirely different human sense. Imagine standing in the heart of a stone chamber, not in silence but surrounded by a low, resonant hum that seems to vibrate through your very bones. This is not science fiction, but a measurable acoustic property of some of the world's oldest monuments. On the island of Malta, buried deep underground, lies the Hal Saflieni Hypogeum, a labyrinthine temple complex carved from solid limestone over 5,000 years ago. Its rooms are shaped like rounded pots or beehives, with curved walls and ceilings that create extraordinary acoustic effects. Certain chambers resonate at a specific low frequency, around 110 Hz. When a person speaks or chants within that space, their voice is transformed, amplified, and enriched by the stone itself, creating an immersive, almost otherworldly auditory experience. Researchers suggest this frequency may have neurological effects, potentially altering states of consciousness, making it a powerful tool for ritual or ceremonial practice. Now travel across the ocean to the stepped pyramid of Kukulkan at Chichen Itza. Stand at the base of its grand staircase and clap your hands once. The echo that returns is not a simple repetition. It is a sharp, chirping sound that uncannily resembles the cry of the Quetzal bird, a sacred creature linked to the feathered serpent god for whom the pyramid is named. This is not an accident of erosion. The staircase's design, the spacing of the steps, acts as a diffraction grating for sound waves, sculpting the echo into a specific, symbolic auditory signature. These acoustic fingerprints force a profound question. If the architecture was engineered to shape sound with such intention, could that sonic design be intertwined with its celestial purpose? This is where speculation becomes truly fascinating. Could a chamber like those in the Hypogeum have been tuned to resonate most powerfully during a specific celestial event, when the sun or moon reached a certain alignment? The idea is that a multi-sensory ritual could have been orchestrated, where the visual spectacle of a solstice sunrise was accompanied by a rising hum from the stones themselves, a harmonic convergence of light and sound. The ceremony would engage the whole body, sight and hearing united, deepening the psychological impact and the sense of participating in a cosmic harmony. It suggests the ancient engineers were not just building calendars or sightlines, they might have been composing experiences. They understood that to truly connect the community with the cosmos, you had to engage more than just the eyes. You had to make the universe sing through the stones. This audio layer adds a rich, emotional texture to our understanding. It moves beyond cold alignment and into the realm of felt experience. A ceremony under such conditions would not merely be observed, it would be absorbed, a visceral, unforgettable merging of the individual with the rhythm of the heavens. The stones become instruments and the sky the conductor in a symphony written for the human spirit. The stones were tuned to sing, but the silence between them holds another kind of music. It is a music of pure mathematics, of numbers and ratios that repeat not just in architecture, but in the orbits of planets and the harmonies of a plucked string. This is where astral engineering transcends alignment and enters the realm of abstract principle, where the monuments become three-dimensional equations. They seem to be expressing a fundamental belief that the cosmos itself is built upon a divine, geometric order, and that by building this same order into their sacred sites, they could tap into the very fabric of reality. The most famous and debated example of this is encoded in the very shape of the Great Pyramid. If you take the perimeter of its square base and divide it by twice its original height, the result is a number astonishingly close to pi, the mathematical constant that defines the ratio of a circle's circumference to its diameter. Pi is an irrational number, a never-ending, never-repeating decimal that was not formally calculated in the West until over 2,000 years after the pyramid was built. How could the builders have incorporated it so precisely into their design? The traditional explanation from Egyptology is one of elegant coincidence born from practical choice. They suggest the builders may have simply used a rolling drum, a circular object, to measure out the base, inadvertently baking pi into the dimensions through a simple physical process. Yet the mathematical echoes grow more complex. Look at the pyramid's internal geometry, and another profound number emerges, the golden ratio, often symbolized by the Greek letter phi. This ratio, approximately 1.618 to 1, appears when a line is divided so that the ratio of the whole to the larger part is the same as the ratio of the larger part to the smaller part. It is found in the growth patterns of shells, the branching of trees, and the proportions of the human body. In the Great Pyramid, the ratio of the length of the slanted apothem, the line from the tip down the center of a face to half the length of the base, is remarkably close to phi. This is not an isolated phenomenon. The same ratio appears in the layout of the Parthenon in Greece, in the spirals of Celtic art, and in the proportions of countless Renaissance paintings. It seems to be a visual harmony that the human eye finds inherently pleasing, but the ancient impulse goes beyond aesthetics. These same mathematical constants are not confined to earthly geometry. Look up. The orbital periods of the planets in our solar system often relate to one another through simple harmonic ratios. The time it takes Venus to orbit the Sun is almost exactly 8/13 of Earth's orbital period. The orbits themselves, while elliptical, can be described by mathematical relationships that fascinated later thinkers like Johannes Kepler, who spoke of the music of the spheres. This creates a breathtaking conceptual bridge. The same irrational numbers and harmonious ratios that govern the growth of a nautilus shell and the structure of a musical scale also appear to be woven into the architecture of the solar system and the dimensions of humanity's oldest stone monuments. So we are faced with a pivotal question. Were the builders intentionally encoding these universal constants? Or were they simply using a system of proportions that felt naturally right, a system that unknowingly mirrored the deeper structure of the cosmos? The answer may lie in a different understanding of knowledge itself. For these ancient geometer priests, mathematics was not a dry, separate science. It was sacred. It was the hidden language of creation, the blueprint the gods used to shape the world. To build a temple using pi or the golden ratio was not a technical exercise. It was a spiritual act of replication. It was an attempt to construct a microcosm, a small, perfect model of the mathematical order they perceived in the macrocosm of the heavens. The monument becomes a point of resonance, a stone tuning fork vibrating in harmony with the mathematical song of the universe. It was a way to make the intangible tangible, to give physical form to a principle, and in doing so, to invite that principle's power into the human realm. This transforms a pyramid from a tomb or a temple into a philosophical statement carved in limestone. It is a declaration that the chaos of the world rests upon an invisible foundation of perfect, eternal number. The silent mathematics of stone finds its echo in the vast, trackless ocean. For some cultures, the stars were far more than symbols for ritual. They were the only roadmaps for survival. While empires built monuments anchored to the earth, the Polynesian voyagers embarked on a different kind of astral engineering, one that used the night sky as a dynamic, moving guide across thousands of miles of open Pacific. Their vessel was not a pyramid but a double-hulled canoe, and their temple was the entire dome of the heavens. These master navigators, long before magnetic compasses reached their shores, developed an astonishing system of wayfinding. They memorized the rising and setting points of hundreds of stars, creating a mental star compass. They did not just see individual stars, they saw star paths, the specific arc a known star would travel from its emergence on the horizon to its vanishing point. By knowing which star rose directly over a distant island, and then watching for the next star to rise in that same spot as the night progressed, they could hold a course. This was celestial precision applied to the most urgent human endeavor, exploration and migration. It required the same deep, generational knowledge of the sky's fixed patterns as building a solstice-aligned temple. But here, the knowledge had to live in the mind and the senses, constantly updated by the feel of the waves, the flight of birds, and the color of the cloud. The connection to our land-based monuments becomes strikingly clear. The same precise understanding of a star's specific rising azimuth, the exact point on the horizon where it first appears, was crucial for both the navigator and the priest-architect. For the navigator, that point was a bearing to a physical destination. For the builder of a temple, that same point might be the direction to orient a doorway or align a corridor, creating a spiritual destination. The knowledge base was identical, only the application differed, one for journeying across water, the other for journeying across the cosmological divide. We see this duality even in isolated stone sentinels. Take the moai, the giant statues of Easter Island. They famously all face inland, their backs to the sea, watching over their communities. But their massive stone platforms, the ahu upon which they stand, tell another story. Many of these ahu are precisely aligned, with some research suggesting orientations toward solstice sunrises or sunsets, or toward important stars for the island's calendar. This suggests a culture that, while rooted to its land, still organized its sacred geography by the same celestial clock that guided their ancestral voyages across the ocean. This practical dimension completes our picture of astral engineering. It was not an either-or proposition, spiritual or practical. It was a holistic understanding that the cosmos governed all things, the growth of crops, the success of a voyage, the legitimacy of a king, and the journey of the soul. The sky was the ultimate source of order, and to align with it, whether by carving a star path into your memory or into a mountain of stone, was to align with the fundamental rhythm of life itself. It reveals a unified world, where survival and sanctity were woven from the same thread of starlight. A single alignment could be a remarkable accident. But what about 5 or 10, or an entire complex of structures all pointing to different, significant points in the sky? This is the critical question at the heart of the archaeoastronomy debate, a field that walks a careful line between awe and academic rigor. Mainstream skepticism is not about dismissing ancient ingenuity, but about demanding proof that withstands statistical scrutiny. The core counter-argument is compellingly simple. With countless ancient sites scattered across the globe, pure probability dictates that some will, by random chance, appear to line up with a major star or solstice sunrise. Finding one alignment at a site might be intriguing, but it is rarely conclusive on its own. To move from coincidence to credible intent, researchers look for a pattern of multiple, independent alignments within the same site, all pointing to celestial events that held cultural significance for its builders. This is where the science gets meticulous. Experts like Clive Ruggles, a leading figure in the field, advocate for a rigorously evidence-based approach. They use statistical analysis to calculate the probability of a set of alignments occurring by chance. If a temple has one doorway aligned to the winter solstice sunrise, that might have a 1 in 365 chance of happening randomly. But if that same temple also has an interior chamber aligned to the rising of a specific star, and an outer wall marking the lunar standstill, the combined odds of all those alignments being accidental become vanishingly small. This method transforms speculation into a quantifiable argument. It forces us to move beyond the visual wow factor and ask deeper questions about the archaeological context. Were the people who built this site known to be keen astronomers from other evidence, like artifacts or texts? Does the proposed alignment match their known calendar or religious practices? A solstice alignment at a farming community's ritual site makes profound sense. The same alignment at a military fortress built far later might not. This balanced perspective is crucial because it protects the truth from both extremes, from outright dismissal of ancient wisdom and from overeager pattern seeking that sees constellations in every pile of stones. It encourages a disciplined kind of wonder, so we arrive at the pivotal moment for any viewer engaging with these ideas. We are presented with two compelling narratives. One sees a grand, global pattern of intent, a shared human impulse to build the cosmos into the Earth, suggesting a depth of prehistoric knowledge we are only beginning to fathom. The other sees a powerful human tendency, pareidolia, to project meaningful patterns onto random arrangements, connecting dots across time and space to tell a story we deeply wish were true. The evidence does not lie cleanly on one side. For every Karnak with its undeniable engineered light show, there is a site where the alignments are tantalizing but ambiguous. The challenge, then, is to hold both possibilities in mind without letting excitement override evidence or letting skepticism blind us to genuine mystery. This is not a debate with a simple winner. It is an ongoing conversation between the stones and the stars, mediated by mathematics. It asks us to be comfortable with uncertainty, to appreciate the profound achievements that are proven, and to remain open yet critical about those that linger in the realm of the possible. The true signature of intent may not be a single beam of light, but a constellation of clues carefully weighed. The statistical debate leaves a profound question hanging in the air. If the alignments are not random and not merely independent inventions, what could possibly explain such a sophisticated, shared blueprint appearing across the isolated continents of the ancient world? One dramatic answer has echoed through legend and speculation for millennia, the idea of a lost source. This is the hypothesis of a forgotten golden age, a time when a deeper understanding of the cosmos was held by a sophisticated culture or network of cultures that was later shattered. Proponents of this view look to a specific, geologically violent horizon, the end of the last ice age, around 12,800 years ago. Scientific evidence points to a period of abrupt, catastrophic climate change, with rapidly rising sea levels and some research suggesting the possibility of impacts from comet fragments. This was not a gentle transition, but a global upheaval that would have reshaped coastlines, drowned entire landscapes now beneath the sea, and potentially triggered a collapse of early human societies. From this chaos, the theory suggests survivors scattered, carrying fragments of a more advanced astronomical and architectural knowledge with them. These scattered seeds then took root in different soils, growing into the varied but conceptually linked traditions we see in Egypt, Mesoamerica, and beyond. It is a narrative that attempts to explain the sudden, seemingly fully formed sophistication of sites like Göbekli Tepe in Turkey, which dates to this turbulent epoch and displays a mastery of stonework and symbolic art that defies conventional timelines. This is not presented as proven history, but as a compelling story that seeks to make sense of the evidence that does not fit neatly into the standard model of gradual, linear human progress. It gives a name to the anonymous teachers, the elusive master architects behind the global pattern. This idea finds a powerful echo not in carbon dating, but in the oldest stories humanity tells. Cultures separated by oceans share eerily similar myths of a great deluge that cleansed the world. Beyond the flood, many traditions speak of civilizing figures who arrived from across the water or from the stars, bearing the gifts of knowledge. The Sumerians wrote of Ons, an amphibious being who taught them astronomy, law, and agriculture. In Mesoamerica, the feathered serpent god Quetzalcoatl was a bringer of civilization, associated with the planet Venus and the arts of the calendar. These are not necessarily literal accounts of visitors, but they could be profound cultural memories. They could represent the arrival of refugee survivors from a lost center of learning, individuals or groups who possessed specialized knowledge of star cycles, mathematics, and monumental construction, and who integrated into new societies as revered teachers. The myth becomes a metaphor for the traumatic dispersal and preservation of a complex worldview. In this light, the global alignment of monuments is not a mystery of independent invention, but a shared inheritance, a common architectural language spoken by cultures who had forgotten they were once part of the same conversation. The stones, then, are not just talking to the stars, they are whispering fragments of a story too old for any living memory to hold, a story of collapse, survival, and the desperate, beautiful human urge to rebuild a shattered understanding of the universe and carve its laws into the bedrock of a new world, ensuring they could never be so easily lost again. That story of a lost world whispers of knowledge far beyond simple alignment. It suggests the ancients saw the earth not as a passive stage for their monuments, but as a living body with its own vital currents. This leads us to the most speculative frontier of this entire mystery, the idea of an ancient energy grid. Here, the theory moves beyond stones marking stars and proposes that the monuments themselves were active devices, placed with precision to interact with the planet's own hidden forces. This concept, explored by researchers like Christopher Dunn, asks us to reimagine the Great Pyramid not as a tomb, but as something akin to a power plant, a machine built from geology and geometry. The foundation of this idea rests on two intriguing premises. The first is the concept of ley lines, or more accurately, telluric energy lines. This is the notion that the Earth has a kind of circulatory system, subtle currents of electromagnetic energy that flow along specific pathways in the crust. Proponents of the theory suggest that ancient sacred sites, from Stonehenge to the pyramids, were deliberately constructed on powerful nodes or intersections of this planetary grid. Their placement, therefore, was not just about a view of the sky, but about tapping into a terrestrial energy source. The second premise involves the very stone they used. So many of these monuments are built from granite, a rock rich in quartz crystals. Quartz has a fascinating property called piezoelectricity. This means that when you apply physical pressure or stress to a quartz crystal, it generates a small electrical charge. Conversely, if you apply an electrical charge to it, it vibrates at a precise frequency. This principle is the heart of every modern quartz watch and many radio transmitters. Now consider a massive granite pyramid sitting on the Earth. It is under constant, immense pressure from its own weight. The theory asks, could the entire structure, acting as a giant composite crystal, be subtly responding to the Earth's natural seismic vibrations, to changes in atmospheric pressure, or even to the gravitational pull of the Moon and Sun? Could it be converting that mechanical stress into a faint, measurable electrical field? When you combine these ideas, the celestial alignments take on a new potential function. If the structure is designed to resonate with terrestrial energy, perhaps its alignments to the solstice sun or specific stars were not just for calendar keeping. They could have been timing mechanisms. The moment a beam of sunlight entered a precisely angled shaft, like those in the Great Pyramid, might have acted as a trigger or a synchronizing pulse, aligning the stone's resonant frequency with a cosmic cycle. In this view, the monument becomes a kind of capacitor or oscillator, harmonizing energy from the Earth below with rhythmic information from the heavens above. It is crucial to state that this energy grid theory exists far outside mainstream scientific consensus. Geologists generally do not recognize the existence of ley lines as measurable energy pathways. The electrical effects proposed, while grounded in real piezoelectric principles, are speculated to be on a scale that has not been empirically verified in these ancient structures. For many archaeologists, it is a step too far beyond the tangible evidence of tools, texts, and societal context. Yet, even as a speculative model, it serves a profound purpose. It challenges our most fundamental assumptions about the purpose of engineering. We think of engineering as building for shelter, for defense, for worship. But what if a civilization developed an engineering philosophy based on a unified field of energy, where earth, sky, and stone were all parts of a single interactive system? Their greatest achievement would not be to create a space, but to create an interface, a place where different layers of reality could communicate. This pushes the definition of technology beyond gears and levers into the realm of resonant harmony. It suggests that the ultimate goal of their celestial precision may not have been to observe the cosmos, but to converse with it, using their mountains of stone as a kind of planetary scale instrument, forever tuned to the silent music of the world and the stars. Our ancestors built their faith into the alignment of stone, but we can now measure that faith with lasers and satellites. The debate over celestial precision is no longer confined to theoretical arguments. It has entered a new era of technological verification. Modern tools are allowing us to see these ancient sites with a clarity their builders could have never imagined, and the results are quietly revolutionary. Using high-precision GPS, we can map the exact coordinates of a monument's foundation with an accuracy of less than a centimeter. Three-dimensional laser scanning, or LiDAR, can create a perfect digital replica of an entire temple complex, capturing every angle and imperfection in the stone. This data is then fed into sophisticated astronomical software, programs that can rewind the night sky to any date in human history, accounting for the slow wobble of the Earth's axis over millennia. This convergence of technologies allows researchers to ask a definitive question: from this specific point on this specific date, what celestial body would have been framed by that doorway or corridor? The answers are removing guesswork and replacing it with mathematical certainty. One of the most stunning validations of this approach comes not from a famous pyramid, but from a row of 13 towers on a barren hilltop in coastal Peru. The site is called Chanquillo, and for centuries its purpose was a complete mystery. The towers are arranged in a neat north-south line along a ridge, like the teeth of a giant comb. From a distance, they seemed like a fortress or a ceremonial center, but their true function remained elusive until archaeoastronomers applied modern analysis. They discovered two precise observation points, one to the east and one to the west of the tower line. From these vantage points, the rising and setting sun would appear to travel along the crest of the towers throughout the year. On the June solstice, the sun would rise at the far left end of the line. On the December solstice, it would rise at the far right. Every day, its position would shift by one tower, creating a solar calendar accurate to within a day or two. This was not a symbolic gesture. It was a fully functional, monumental timekeeping device, a solar observatory built over 2,000 years ago. The technological verification at Chanquillo was conclusive. The alignments were intentional, repeatable, and engineered for a clear, practical purpose. It stands as one of the cleanest, most empirically solid examples of ancient astral engineering ever documented. This process of technological verification is acting as a powerful bridge across time. It allows our science to confirm their science, creating a dialogue between epochs. When a laser scan confirms that the central axis of Karnak is off true east by a fraction of a degree, and astronomical software shows that this slight offset perfectly captured the solstice sun in the year it was built, the alignment transforms from a suggestive possibility into a documented fact. It shifts the conversation from whether they could do it to understanding the breathtaking consistency with which they did it. This empirical layer does not strip the monuments of their mystery. Instead, it deepens our respect for the intellect behind them. We are not projecting our patterns onto their stones. We are using our most advanced tools to read the patterns they deliberately left for us. The silent dialogue between the temple and the sky is now a conversation we can finally hear in the language of data, a conversation that confirms a shared human capacity to observe, calculate, and build in harmony with the cosmos. The data from our lasers and satellites confirms their precision, but it cannot measure the spell these stones have cast on the modern imagination. These mysteries of astral engineering do more than rewrite history books. They actively reshape our view of the human story itself. This is why the topic burns so brightly in popular culture, fueling countless novels, blockbuster films, and passionate online communities dedicated to alternative history. At its core, this fascination taps into a profound and very human longing, a desire to find evidence that our ancestors were not primitive but profound, that they possessed a wisdom we have since forgotten. We are drawn to the idea of lost grandeur, of a golden age whose echoes we can still hear in the alignment of a pyramid or the mathematics of a temple. It is a narrative that offers a deeper sense of connection, not just to the past, but to a cosmos that feels intentionally designed, rather than randomly assembled. In our current age, defined by climate uncertainty and an often dizzying technological disconnect from the natural world, these ancient monuments stand as powerful counterpoints. They represent a time when humanity did not see itself as separate from nature, but as a conscious participant within a living, breathing universe. The very act of building Karnak to catch the solstice sun was a declaration of partnership with cosmic cycles, not dominion over a passive environment. This challenges perhaps our most deeply held modern belief, the linear narrative of progress. We are taught that knowledge accumulates in a straight, upward line, from simple to complex, from primitive to advanced. Yet the stones whisper a different possibility, that civilization may not be a steady climb, but a series of peaks and valleys. They suggest that profound understanding can be achieved, and then, through catastrophe or the slow erosion of time, can be lost, only to be painstakingly rediscovered millennia later. This is a humbling thought for a civilization that stores its collective memory in digital clouds. It asks us to consider what of our own towering achievements might one day be reduced to enigmatic ruins, their original purpose a subject of future speculation. This possibility is not frightening but strangely inspiring. It places our current moment within a much grander, more cyclical timeline. It suggests that the drive to understand the cosmos and build meaning from it is not a modern invention, but a perennial human trait. When we stand before these monuments, we are not just looking at ancient engineering. We are looking into a mirror that reflects our own deepest questions about purpose, legacy, and our place in the great story of the universe. They become waypoints not just for the sun, but for the human spirit, reminding us that the quest to align our lives with a greater order is a journey as old as humanity itself. The most profound technology for understanding the cosmos remains free and available to every single one of us. It requires no software, no instruments, and no specialized training, only a willingness to look up with a patient and curious eye. You can begin your own journey of celestial observation tonight by stepping outside and simply reconnecting with the raw, unfiltered data that was the foundation of every monument we have explored. This practice is not about becoming an expert astronomer. It is about reclaiming a fundamental human experience, seeing the sky as a dynamic map rather than a static decoration. Start with the most reliable fixed point in the northern sky, Polaris, the North Star. On a clear evening, find the Big Dipper, that familiar saucepan shape. Use the two stars at the front edge of its bowl, often called the pointers. Draw an imaginary line upward from them, about 5 times the distance between those two stars. Your line will land on a moderately bright star that seems to stand alone, with the rest of the sky slowly rotating around it. That is Polaris. For the ancient builders, finding this unmoving center was the first step in establishing true north, the sacred axis for their entire world. Once you have found your anchor, turn your attention to the moon. Do not just glance at it, observe its cycle over a month. Note its changing shape from a thin crescent to a full, brilliant disk and back again. Pay attention to where it rises each night. You will see it travels along a path similar to the sun's, but shifts more dramatically from night to night. The ancient sky watchers used the moon's phases to mark shorter periods of time, to schedule ceremonies, and to track the more complex Saros cycles that predicted eclipses. Your most powerful long-term project, however, requires a consistent viewing spot, perhaps a window you look out each morning. Choose a place where you can see the eastern horizon. Over the course of a year, make a mental note, or better yet, keep a simple journal marking where the sun crests the horizon. You will witness its grand migration. In the heart of summer, it will rise far to the northeast. As the months cool, its rising point will march steadily southward, until on the winter solstice it breaks the horizon at its most southeastern point. This slow, majestic dance is the very rhythm the builders of Stonehenge and Karnak sought to capture and eternalize in stone. By noticing this shift yourself, you internalize the reason for their immense labor. You are not just learning a fact, you are feeling the celestial pulse that dictated the planting of crops, the timing of floods, and the turning of their ritual year. This personal act of observation demystifies the entire concept of astral engineering. It reveals that the genius of the ancients was not in possessing secret tools we have lost, but in the disciplined, generational commitment to noticing patterns we often ignore. They took what anyone could see and built a civilization upon it. Your own journal, with sketches of the moon or notes on the sun's position, becomes a direct link to that timeless human endeavor. It transforms the distant, monolithic mystery into a living conversation between your eyes and the same stars that guided them. When you next hear about a solstice alignment or a lunar standstill, you will not just understand it intellectually, you will have a memory in your muscles, a sense of the sky's slow turn that no documentary can ever provide. This connection is the true legacy of their work, an invitation written not in stone but in light, waiting for anyone who chooses to look up and begin. That personal sky journal is your first step into a living tradition. The second practice requires leaving your home and stepping into the landscape itself. Research if there are any local ancient sites within your reach, perhaps a Native American burial mound, a colonial-era stone wall built on an old ley, or even a historic church or civic building known for an unusual orientation. Many towns have structures whose foundations were laid with a regard for the sun or stars that has long been forgotten. Your visit now shifts from passive tourism to active field observation. Approach the site with a new intent. Before you even look at an information plaque, stand before it and ask simple, physical questions. What direction does the main entrance or facade face? Use a basic compass app on your phone, remembering that magnetic north differs slightly from true north, but it will give you a strong general idea. Now, observe the horizon. If the entrance faces roughly east, could it be aligned to a sunrise? If it faces west, perhaps a sunset. Does the structure have any obvious corridors, windows, or gaps that seem intentionally framed? The key is to look for intention in the placement. A solitary standing stone in a field is one thing, but if that stone is part of a larger pattern, or if it clearly frames a notch in a distant hill when you stand behind it, the possibility of design grows stronger. This transforms a casual weekend outing into a personal archaeological investigation. You are no longer just seeing a ruin, you are interrogating it. You are gathering your own primary data, just as an archaeoastronomer would, albeit on a simpler scale. The goal is not to prove a grand theory, but to cultivate a way of seeing. When you stand at that local mound and consider that its builders may have positioned it to catch the first light of the summer solstice, you forge a tangible link between your place and the global pattern. The mystery ceases to be a distant spectacle about pyramids and becomes a question embedded in your own regional soil. It makes the abstract intimately concrete, reminding us that the impulse to harmonize with the cosmos was not confined to famous deserts and distant mountains, but is a human signature that could have been written anywhere people settled and looked up. This act of local discovery is where the past truly comes alive, not through a screen, but through your own direct observation of alignment, light, and land. Your own observations and local explorations build a vital foundation, but the modern world offers a powerful extension of your senses. A third practice transforms your computer or smartphone into a personal time machine for the sky, allowing you to simulate the very celestial conditions the ancient builders witnessed. This is where you move from being an observer to becoming a virtual archaeoastronomer, equipped with tools that were once the stuff of science fiction. Free and low-cost planetarium software, like the open-source program Stellarium, or a variety of accurate smartphone apps, put the entire historical sky in the palm of your hand. These programs contain databases of millions of stars, planets, and deep sky objects, and their real power lies in their ability to rewind time. You can set your location to anywhere on Earth, from the sands of Giza to the hills of Salisbury Plain, and then dial the date back thousands of years with a few clicks or taps. The screen instantly renders the night sky exactly as it would have appeared from that spot on that specific historical night. This is not an approximation. It is a precise mathematical reconstruction based on our modern understanding of celestial mechanics. The first time you use this tool, the effect is genuinely profound. Let's take the Great Pyramid as an example. Open your chosen software and set your location to the Giza Plateau. Now, instead of looking at today's sky, wind the date back to around 2500 BCE, the widely accepted period of its construction. Turn off the modern constellation lines and labels and simply look at the raw, brilliant stars as the pyramid's architects would have seen them. Now find the southern sky. There, blazing prominently, you will see the 3 stars of Orion's belt. Look at their orientation, their brightness relative to each other. You can then pull up an aerial map or diagram of the 3 main pyramids on the ground. The visual correlation when you hold the 2 images in your mind is striking and immediate. You are no longer relying on someone else's description or artist's rendering. You are seeing the potential pattern for yourself. You can go further. Use the software to check the alignment of the celestial pole. In 2500 BCE, the star Thuban in the constellation Draco would have been circling very close to the true north celestial pole. Now look at the pyramid's near-perfect cardinal alignment. The connection between the earthly structure and the heavenly pivot becomes a tangible relationship you can explore. This digital exploration empowers you to test theories and form your own educated impressions. Was a certain temple doorway truly aligned to the rising of the star Sirius? Set the date and location and watch the virtual dawn. You can see if the star's first gleam would have been framed by the stones. This process demystifies the academic work and makes it participatory. It allows you to engage with the mystery on a level of evidence, moving beyond speculation into a space of personal discovery. The software becomes your telescope into the past, a way to stand beside the ancient astronomers and see what they saw, to understand the canvas upon which they decided to paint their monumental legacy. With this tool, the grand narrative of astral engineering is no longer a closed book written by experts, but an interactive story that anyone can open and explore, one starry night at a time. The sky's silent dialogue with stone is a heritage that belongs to every one of us, but that shared inheritance comes with a profound responsibility. Our modern fascination with these sites carries a tangible weight, for the very act of seeking their secrets can, if done carelessly, contribute to their loss. This brings us to an essential and often overlooked dimension of this entire mystery, the ethics of preservation and respect. Many of these monuments are not abandoned relics of a dead past. For indigenous cultures around the world, from the Andes to the Australian outback, they remain active, living sacred sites, integral to spiritual practice, community identity, and cultural continuity. To treat them merely as open-air museums or backdrops for social media is to ignore their enduring heartbeat. Furthermore, the pressures of mass tourism, combined with the escalating impacts of climate change, pose existential threats to these fragile stone calendars. Increased foot traffic erodes ancient pathways. The moisture from thousands of breaths can degrade painted walls inside tombs, and the simple act of touching a carved surface transfers oils that accelerate weathering. Rising sea levels threaten coastal sites, while more extreme temperature fluctuations and intense storms test stonework that has endured for millennia. Our desire to connect with this wonder must be balanced with a commitment to ensure it survives for generations yet to come. This begins with the choices of each individual visitor. It means following established guidelines, staying on marked paths, never touching carvings or climbing on structures unless explicitly permitted. It means understanding that a photograph is not worth trespassing past a barrier or ignoring a sacred protocol. When visiting a site that is still used for ceremony, it requires a posture of quiet observation, recognizing that you are a guest in a space that holds deep, ongoing meaning. Supporting legitimate preservation efforts is another crucial step. This can mean choosing tour operators who prioritize sustainability and give back to local communities, or donating to organizations dedicated to archaeological conservation and climate resilience for cultural heritage. The goal is to shift from being a consumer of mystery to becoming a steward of the message. The knowledge encoded in these alignments is not locked away. It is written on a parchment of landscape and limestone that is vulnerable to fading. Our collective curiosity should fuel protection, not degradation. To stand before the Intihuatana or within the passage of Newgrange is to be granted a privilege, a momentary audience with a conversation between humanity and the cosmos that has lasted for thousands of years. Our role is to listen, to learn, and to ensure that the conversation is never interrupted, so that future seekers can also stand in that same light and feel the same awe. asking their own questions of the silent, waiting stones. The map of our ancient world is being redrawn not by shovels but by lasers. A quiet revolution is unfolding above the jungles of Central America and Southeast Asia, where a technology called light detection and ranging, or LiDAR, is peeling back the green veil of the canopy to reveal landscapes we never knew existed. Mounted on aircraft, these laser scanners fire millions of pulses of light toward the ground. By measuring the time it takes for each pulse to bounce back, they can construct a three-dimensional map of the terrain below, filtering out the dense vegetation to show the bare earth beneath. What is being uncovered is nothing short of staggering. In Cambodia, LiDAR surveys over the Angkor region revealed a vast, low-density urban sprawl connecting the famous temples, a sophisticated network of canals, roads, and village mounds that suggests a metropolis of nearly 1 million people. In the jungles of Guatemala, scans have exposed tens of thousands of previously unknown structures around known Maya cities like Tikal, revealing immense fortifications, agricultural terraces, and complex road systems that rewrite the scale of their civilization. These are not just new buildings, they are entire lost cities, hidden for centuries, now emerging into the light of our understanding. This technological leap transforms archaeology from a slow, pinpoint excavation into a wide-angle revelation. It allows researchers to see the grand design, the overarching urban and ceremonial layout that was invisible from the ground. And within these newly revealed city plans, a thrilling possibility awaits. As archaeologists begin to ground truth these LiDAR maps, they will not just be cataloging palaces and plazas, they will be analyzing their orientations. Every new major structure, every ceremonial platform and causeway presents a fresh opportunity to search for celestial alignments. We must now ask, within this vast, newly discovered Maya metropolis, are there structures purposefully aligned to the Venus cycle or to solar zenith passages unique to that latitude? Could there be an entirely unknown class of observatory, a configuration of buildings that tracks celestial events in a way we have not yet documented? Each discovery has the potential to add a new data point to our global understanding of astral engineering, revealing regional variations or confirming universal principles. The jungle, it turns out, has been guarding not just stones but entire chapters of humanity's celestial conversation, and the sand holds equal promise. Satellite radar and ground-penetrating radar are beginning to probe beneath the deserts of Egypt and the Middle East, hinting at undiscovered chambers near known monuments and tracing the outlines of buried settlements that may have housed the builders themselves. These tools act as a non-invasive key, allowing us to ask questions of the Earth without disturbing a single grain. What if a scan reveals a previously unknown annex to a temple, one whose doorway creates a solstice alignment too precise to be ignored? What if the layout of a buried workers' city mirrors a constellation pattern, suggesting the astronomical knowledge was woven into the fabric of daily life, not just reserved for the elite? Every such discovery would add another layer of context, moving us from wondering about isolated monuments to understanding them as part of a living, breathing cosmological landscape. This forward momentum ensures that the story is far from over. We are no longer simply interpreting the ruins left to us, we are actively finding new pages of the manuscript. Each laser pulse and radar echo is a question sent into the dark, and the answers coming back are reshaping history in real time. The greatest monument to ancient wisdom may not be any single pyramid or temple, but the vast, hidden network of their connections, now slowly coming into view, waiting to tell us how deeply and how brilliantly the human mind once mapped the stars onto the face of the Earth. These stones ask a quiet question of our own time. We live beneath a sky often washed pale by the glow of our cities, a celestial map we glance at but rarely truly read. Our calendars are digital notifications, our navigation comes from satellites we cannot see, and the profound rhythm of solstices and equinoxes passes for most of us as just another change in the weather. In this context, the silent, patient astronomy of the ancients can feel like a forgotten language. Their monuments stand as a mirror, reflecting back a fundamental choice about how to live within the universe. They chose engagement over observation, participation over passivity. They built to join the conversation. So what does that mean for us? We may not need to chart the stars to plant our crops or navigate an ocean, but we may need their light for something just as vital, a sense of perspective. In the rush and noise of daily life, it is easy to feel that our world, with all its complexities, is the only world that exists. These ancient sites pull our gaze upward and outward. They remind us, in the most physical way possible, that we are standing on a rocky sphere hurtling through a void, orbiting a star that is one of billions, in a galaxy that is one of trillions. This is not meant to diminish our concerns, but to contextualize them within a breathtaking cosmic story. The awe that drove a culture to move an 80-ton stone to mark a sunrise is the same awe available to us when we simply step outside on a clear night, away from the screens, and look up. That feeling of smallness is not loneliness, it is connection. It is the realization that the same laws of geometry and motion that govern the dance of planets also guided the hands that shaped these stones. We are made of the same stardust, looking out at the same constellations, asking variations of the same eternal questions. The monuments are bridges across time, not to a lost golden age, but to a perennial human capacity for wonder. They challenge us to reclaim just a fragment of that sky-watching patience, to notice where the moon rises tonight, to mark the changing place of sunset over your own rooftop across the seasons. In doing so, you are not just learning an astronomy fact, you are realigning your own internal rhythm with the grand, slow pulse of the cosmos. You are remembering that you, too, are part of this ancient, ongoing story, a conscious participant on a planet that is itself a kind of ship sailing the starry ocean. The final lesson of astral engineering may have nothing to do with lost civilizations or advanced technology. It may simply be an invitation, carved in stone and written in light, to look up, to feel the wonder, and to find your own place in the vast and beautiful narrative of the universe. The stones have given us their alignments, but they guard their final secrets closely. For every beam of sunlight we can now verify, a deeper shadow of mystery remains, questions that pull us further down the rabbit hole of history. The first and perhaps most profound unknown is the true age of our oldest sites. While mainstream archaeology provides dates based on carbon samples and pottery styles, the celestial timestamps suggested by Precession point to potentially far older origins. This disconnect is not easily resolved. Were the builders of Göbekli Tepe or the Sphinx working from a knowledge of the sky that was already ancient in their own time, a legacy passed down from a forgotten epoch? Or are our current dating methods missing crucial pieces of the puzzle? The debate between established chronology and celestial evidence remains one of the field's great, unresolved tensions. Equally puzzling is the question of transmission. If there was a shared cosmological blueprint, how did it travel? We have no evidence of Phoenician ships crossing the Atlantic, or of Chinese junks reaching Peru in deep antiquity. The idea of independent invention is powerful, yet the similarities in precision can feel uncanny. Could the transmission have been more subtle, a slow diffusion of core ideas along trade routes over millennia, carried not by architects but by storytellers, healers, and migrating clans? Or does the answer lie in a common human neurology, a hardwired capacity to recognize certain geometric and astronomical patterns as sacred, leading cultures to similar conclusions entirely on their own? We simply do not know. Then there are the more speculative frontiers, like the theories of telluric energy and piezoelectric properties. While fascinating, they exist in a realm where hard evidence is elusive. Can science ever design an experiment to prove the Great Pyramid was a machine for harnessing planetary vibrations? Or will these ideas remain in the domain of compelling thought experiments? The challenge is to explore these possibilities with open-minded rigor without letting excitement outpace verification. Ultimately, we are left asking the biggest why. Why this global, obsessive drive to anchor society to the stars? Was it purely for practical survival, for political control, for spiritual assurance? Or was it something more profound, a fundamental human need to externalize our search for meaning, to build our existential questions into the landscape so they might be answered by the cosmos itself? The monuments stand as a collective cry into the celestial void, and we are still listening for the echo. This is why the investigation is vibrantly alive today. Institutions like the University of Chicago's Oriental Institute, teams using LIDAR in Central America, and independent archaeoastronomers crunching data in their home offices are all part of a new chapter. They are not just digging up artifacts, they are scanning, modeling, and simulating, applying 21st century tools to humanity's oldest puzzles. Every new satellite image, every ground-penetrating radar survey, holds the potential to tilt the scales of a decades-old debate. The conversation is no longer confined to academic journals. It thrives in online forums, documentary films, and the notes of amateur sky watchers. This means the next crucial observation, the next piece of the puzzle, could come from anywhere. It could come from you the next time you notice a strange alignment in a local ruin, or when you use software to test an idea about a distant temple. The story of astral engineering is not a closed book written in stone. It is an open invitation, a mystery still being decoded, waiting for new eyes to look up and see the connections we have all missed. The silent stones have spoken across continents and millennia, and their message is now clear. They stand not as ruins of a forgotten past, but as enduring proof of a shared human ambition. This global tapestry of astral engineering, from the solstice beam at Karnak to the shadowless pillar at Machu Picchu, reveals a universal impulse. It is the profound desire to reach beyond our earthly confines and weave the majestic, predictable rhythms of the cosmos into the very fabric of our world. Whether these precise alignments served as sacred calendars for survival, instruments of spiritual communion, or even attempts to harmonize with a hidden energy of the earth itself, they collectively point to a breathtaking depth of ancestral ingenuity. These monuments were their interface with the universe, a way to make the infinite tangible, to give form to wonder, and to seek meaning under the same stars that watch over us today. They challenge our modern narrative of linear progress, suggesting instead that profound understanding can arise, be lost, and patiently await rediscovery. So let these silent sentinels be more than a historical curiosity. Let them be an invitation. Tonight, step outside. Let your eyes adjust to the darkness. Find just one familiar star or trace the path of the moon. In that simple act of observation, you are participating in the same ancient dialogue, using the same original technology, the human mind filled with awe. You become part of the continuum that stretches back to the first architect who laid a stone to mark a sunrise. The greatest chapters of our shared story are not locked away in dusty tombs. They are written in the living light above us, waiting for anyone who chooses to look up and begin reading. If this journey through the marriage of stone and starlight has sparked your curiosity, consider joining our community of explorers. Your support helps us delve deeper into these mysteries, so if you wish to continue unraveling the puzzles of our past, subscribing is a wonderful way to stay connected. We would love to hear which monument or alignment resonated most with you, so feel free to share your thoughts in the comments below. The conversation between humanity and the cosmos is eternal, and your voice is now a